from a safety perspective, it was important to us that that when our customers go out and they buy a vehicle, this is stamped with the Toyota badge, and this means that we've gone through exhausting measures to ensure that they have equivalent, if not greater, safety than they have in any vehicle that we provide.
We conduct typically over 100 full-scale crash tests. Of course, we look at side impact, front impact, we look at impacts with narrow objects, we look at vehicle to vehicle, we look at rear impacts. We also needed to look at how to protect the occupant and the first responder in the event of a crash involving high voltage components.
For frontal impact, obviously we removed the engine, a traditional internal combustion engine from the vehicle, replaced it with electric motor, other high voltage components, which greatly changed the deformation mode of the front end of the vehicle. So we had to do many creative things.
The primary objective was to make sure that when we get into an unplanned event, like an accident, we close down and isolate the high voltage in the battery, and we protect that battery so that we can have a secure containment for that energy.
In the front end crashes, front compartment and barrier are pushing the inverter, and inverter starts hitting other surrounding parts, but we didn't want that. So we added a strong structure that keeps the space and push the whole components rearward, and then it starts reaching the battery, which is a high voltage component, and we didn't want to hit that. So we set the ramp that guides the whole package downwards to prevent the hitting the battery.
We have multiple redundant systems on both the component level, on the system level, and then again on the full vehicle level to ensure that this vehicle operates as safely as any other vehicle that we put out on the road.
One of those notable redundant design philosophies was something we implemented, a device called a pyrotechnic safety switch. And what the pyrotechnic safety switch is essentially a small guillotine that breaks the circuit. By breaking this circuit, we prevent current from flowing out of the battery. What that means to the occupant is within just a few milliseconds after impact, all of the current will stop flowing out of the battery. And then within just a few seconds after impact, you won't have high voltage anywhere within the vehicle except for the battery itself.
Beyond the actual vehicle level, we went into component level testing, flooding different electrical components to ensure that were they submerged while they were active, that they have a proper shutdown protocol and that they're isolated and that they don't provide any danger to the occupants or to first responders who might be responding to that scene.
We went through our due diligence of performing just numerous amounts of tests. We wanted to make sure that the battery was isolated from any damage. We wanted to make sure that our drive inverter was protected in front crash, side crash, rear crash. We even took it up and beyond what you normally would see in federal requirements. We made sure that we took the weakest area for our side impact and we crashed it there to make sure we were not receiving any kind of internal damage to the battery or providing any sort of isolation loss.
I think the safety is one of the most important performance that body design can provide customer. So I hope customer would never use that performance, but just in case of accident, they'll still be protected by the body structure we designed.
I think in this project we ended up with 13 patents from safety regarding battery protection safety. So you have to be innovative.
Our engineers did a phenomenal job in packaging and in securing the battery in the vehicle position that it's in right now. And the amount of vehicle tests that we've done and the due diligence that they paid has been just phenomenal.